In this lesson, we are going to be dividing polynomials using long division, dividing polynomials using synthetic division, and also solving polynomials using synthetic division. We quickly want to recall how we learned how to do long division in elementary school. So what we did was we decided how many times does 3 go into 7. We wrote that on the top, and we multiplied the 2 and the 3 together to get 6. And then the biggest thing to remember is we subtracted. Once we subtracted, we brought down the next number. Then we decided how many times 3 went into 12. Went in there 4 times. 3 times 4 is 12. And remember, please, to subtract. Since that's 0, we brought down our next number, and we decided how many times 3 went into 8. Goes in there 2 times. 3 times 2 is 6, and we subtracted. And then we had 2 left over. And when we first learned how to divide, we did not use a decimal. We wrote remainder 2. And then we moved into decimals and fractions, and we learned how to write our remainder as a fraction by taking the remainder and putting it over the divisor to create our fraction. We're going to do the same thing with polynomials when we do long division. However, if you are only dividing by a monomial, you can either do the long division, or you can simply divide by the monomial and have fractions. Let me show you what it would look like with long division. So if I have long division, I'm going to put my divisor on the outside, and I have my polynomial underneath, and I'm going to divide. So I want to ask myself, how many times does x go into x cubed? It goes in there x squared times. So I multiply x squared times x, put my product, and then I subtract. And then I bring down the next number. How many times does x go into x? It goes in there 1 time. So I multiply 1 times x, which gives me a product of x, and then I subtract, and I get 0, so I bring down the next number. And then I ask myself, how many times does x go into 5? And it doesn't, so that's going to be our remainder. It is a positive 5, and we write the remainder then as plus our remainder over our divisor, which is 5 over x. So we can do that by long division. Or, if you again have just a monomial as your divisor, you can simply divide each of the terms by 2x and simplify. So 10x cubed divided by 2x is 5x squared. 8x squared divided by 2x is 4x. Negative 7x over 2x gives us negative 7 over 2, which could also be written as a mixed number or as a decimal. And then finally I have negative 1 over 2x, and since that can't be divided, it just leaves me with negative 1 over 2x. In the next example, we are going to do long division, but this time we're going to be dividing by a binomial. So I have 2x minus 1, and I'm going to divide that into 4x squared plus 10x minus 5. Same process, even though it's a little bit more complicated with more terms. So I ask myself, what can I multiply times 2x to get 4x squared? I can multiply it by 2x. So now I'm going to take 2x times 2x, which gives me 4x squared, and I'm going to take 2x times negative 1, which gives me negative 2x. But the biggest thing to remember, as we talked about in the previous slide, is that we are going to subtract. Subtract. So subtracting a negative will change it to a positive. So I'm going to combine like terms, which gives me 12x, and I'm going to bring down the negative 5. I ask myself, what do I multiply times 2x to get 12x? I'm going to multiply it by 6. So 6 times 2x is 12x, and 6 times negative 1 is negative 6. But I need to remember to subtract, and then subtract, which changes that to a positive 6. So when I combine like terms, I have one remainder, and it's a positive 1. So I'm going to put my remainder 1 over my divisor, which is 2x minus 1, and that's how you write the remainder. Let's do another example. So I have x plus 4, and I'm going to divide that into 2x squared plus 3x minus 20. So I say to myself, what am I going to multiply times x to get 2x squared? 2x. Now I multiply 2x times x, and I get 2x squared, and I multiply 2x times 4, and I get 8x. But again, remember that we are going to subtract, so we have to subtract both of the terms. That leaves me with negative 5x, and I'm going to bring down my negative 20. What do I multiply times x to give me negative 5x? Negative 5. Now I will multiply negative 5 times x and negative 5 times 20, and I get negative 20. Please remember to subtract, which changes the signs of both. In this case, I have a sum of 0, and so I do not have a remainder. My quotient will be 2x minus 5, my solution. Let's take a look at one more example with long division. So we have x minus 1, and I'm going to divide that into x cubed minus x squared minus 2x plus 8. What do I multiply times x to get x cubed? I multiply it by x squared. So I multiply x squared times x, and that gives me x cubed, and x squared times negative 1, which gives me negative x squared. Please remember to subtract, which changes the signs of both of the terms, and now I combine. So I bring down my next term, which is negative 2x, and I bring down the 8, since those had a sum of 0. Now I ask myself, what do I multiply times x to get negative 2x? I multiply it by negative 2. So negative 2 times x is negative 2x, and negative 2 times negative 1 is a positive 2. Now I need to subtract. So when I subtract, I'm going to change the signs. This one becomes positive, and this one becomes negative. That gives me a remainder of positive 6. So to write my remainder, I write positive 6 divided by x minus 1 for long division. Since synthetic substitution gives us the coefficients of the quotient, it's sometimes also called synthetic division. And we can use synthetic division to divide a polynomial expression of the form x minus k. So let's take a look at example 3, and instead of using long division, we're going to use synthetic division. Here's how we can think about this. We want to do what one of our solutions is, or what x equals when we do our synthetic division. So if we have x minus 1, we could set that in essence equal to 0, so that one of our solutions is really x is equal to 1. So that's how we did our synthetic substitution before, and synthetic division is going to be done the same way, basically the same thing. So we're going to list our coefficients. We have our 1, our negative 1, our negative 2, and our 8. And then remember, we bring down the 1, we multiply, we add the 2 together, we multiply, we add the 2 together, we multiply, and we add the 2 together. And then this is really called our remainder theorem, because this number right here, the 6, is going to serve as our remainder. So when we're done, this lists our coefficients. So when we divided, we have our x squared left, so this will be 1x squared, and We don't have any, we'll have 0x, so we won't write that. Minus 2 is our constant term, and then our remainder is 6, so it'll be plus 6 over our divisor, and our initial divisor was x minus 1, so that's what we will put as our denominator. And that is, when we divide, that will be our answer, and using synthetic division. So let's try another example with synthetic division. Again, we set the x minus 7 equal to 0, so we're going to divide by 7. X is equal to 7. And we'll list our coefficients. We have 2, negative 9, negative 32, and minus 21. We bring down our first, which is 2. We multiply the 2 together, and then we add. We multiply the 2 together, and then we add. We multiply the 2 together, and then we add, and we have our final answer of 0. So that means we are not going to have a remainder. So we have our final as 2x squared plus 5x plus 3, which gave us the coefficients when we did our division, and we had divided by x minus 7 using synthetic division. Now, we can also use synthetic division to find all of our solutions when we're solving our polynomial. So, we're going to start with our synthetic division. We're going to use our x is equal to negative 4 is one of our solutions, and it's our job to find the others. So we list our coefficients, 3, 13, 2, and negative 8. We're going to bring down the 3 and multiply the 2 together. Then we add, and we multiply the 2 together, and then we add, and we multiply the 2 together, and with our remainder of 0, we knew that that was one of our solutions, x is equal to negative 4. So now these are the coefficients of our remaining polynomial. We have 3x squared plus x minus 2, and we're going to set that equal to 0 and finish solving. And now we can solve by factoring because we have a quadratic. So we'll find our other solutions in this way. 3x times x will give us 3x squared, and then 2 times 1 will give us 2. And if I place those two numbers in these positions, I can check that I have 3x times 1 gives me 3x, and 2 times 1 gives me 2x. And I want to be able to have a sum of 3x and 2x to give me 1x, which means I want to make my 2x negative and my 3x positive. So now I'm going to set those equal to 0. So I have 3x minus 2 equal to 0. And when I solve, I have x is equal to 2/3. And I have x plus 1 is equal to 0. And when I solve, I have x is equal to negative 1. And I began with my other solution, which was x is equal to negative 4. And those are my solutions to my polynomial function using synthetic division. Let's try another example. So I know that x equals 5 is one of my solutions. So I'm going to use synthetic division to find my other solutions. I list my coefficients. I have my x cubed. I don't have an x squared. I have my negative 19 and my negative 30. So I bring down that first leading coefficient. I multiply and I add the two together. I multiply and I add the two together. I multiply and I add the two together, and we want to make sure that we end with 0 so that now we have our remaining as our coefficients of our quadratic. So that gives me a 1x squared plus 5x plus 6. Setting that equal to 0, we can solve by factoring. So we have x and x. What two numbers can I multiply together that give me 6? But when I add them together, I get 5. That would be positive 3 and positive 2. So when I set those equal to 0 and solve, I have x equal to negative 3, x equal to negative 2, and we began our problem with the first solution, which is x is equal to 5. Let's try another example. X is equal to 5 is our first solution. So we have our negative 5, and we're going to do our synthetic division. We have 1, 6, 3, and negative 10. We bring down the first leading coefficient, and we multiply that. Then we add the two together. We multiply. We add the two together. We multiply, and we end with 0, which means that we now have our remaining numbers as our coefficients of our quadratic. So we have x squared plus x minus 2. To solve, we're going to set that equal to 0, and we're going to factor. So we have x times x is x squared. 2 times 1 would be 2. And since I want to add the O and the I of FOIL, the middle terms together, to get a positive 1x, that means I'm going to have a positive 2 and a negative 1. So when I set them equal to 0 and solve, I have x is equal to negative 2, x is equal to positive 1, and we began our problem with x equaling negative 5. Those will be our three solutions to our polynomial function. Let's try one where we have an x to the fourth. So we begin with our first solution as x is equal to 1. Now we list our coefficients. X to the fourth, that coefficient is 1. We don't have an x to the third. X squared coefficient is negative 5. We don't have an x, and our constant term is 4. So we bring down the leading coefficient. We multiply the two together and add. We multiply the two together and add. We multiply the two together and add. We multiply the two together and we add, and we get 0. So we have 4 terms, meaning that now we have an x cubed, x squared, minus 4x, minus 4, and we're going to set that equal to 0. Our polynomial is written in standard form. There are 4 terms, so we're going to use factor by grouping. So we have x squared as our common factor, and when we divide we get x plus 1. We have negative 4 as our common factor, so we have x plus 1. So we have x squared minus 4 as our first binomial, and x plus 1 as our second binomial. But when we want to factor completely, we recognize that this is the difference of squares pattern, which can be factored into x plus 2 and x minus 2. And then we have our x plus 1. So when we solve and set each of these equal to 0, we have x is equal to a negative 2, x is equal to a positive 2, x is equal to negative 1, and we began our problem with x being equal to a positive 1. Those will be our 4 solutions for our polynomial function. So, in review, when you are doing polynomial long division, remember that that's a method used to divide polynomials, similar to the way that we divided numbers when we began in elementary school. But we can also solve the polynomials by using synthetic division, which is a method you use to divide a polynomial by the expression of the form x minus k.